Hello, this is Nature Nerd 1000, and welcome to another lesson in my Conlang series called Ancient Binary. This is a number Conlang, and I'll have links to the other videos down in the description. But today we're just going to learn just some basic shortcuts in Ancient Binary, and I'm gonna do some maybe practice problem, and I'll show you the system for division, addition, and subtraction and multiplication and stuff in Ancient Binary. Also addition. So basically, this is a number chart. This shows 1 through 20. So basically, Ancient Binary is just a basic system of just adding up 1 through 6 through placement lines. They're kind of like characters, and then you just add it up, and you just keep going up one by one, and you just keep moving the line. See, this is 6 plus 1, that's 7. 6 plus 2, 8. 6 plus 3, and then so on. And then it has the potential to go to base 22, but because it's a lot easier to count in 20s, then I decided to limit it to 20, and also have it like the ancient Mayan society. And see, hopefully this will be used in a different world. Now, as you can see on this chart, this is a few basic numbers, 1 through 20, and then it's just practices adding 1. So see, this is 20. This is the placeholder. And then see 20 plus 1, 20 plus 2, and that just practices 21 and 22. And then it does something else too. It goes to 30. See, 30, normally that would be, we'd change this part because it would be base 10, but this is base 20. So basically this is 20 plus 10, because this is 6 plus 4. So basically 20 plus 10 equals 30, so that's why it's 30. And then it also practices 39 right before 40, and we move to 2 sets. See how it goes up to 2 sets of 20. So basically this is the maximum ones digit place, 39. 20 plus 19. 20 plus 19 equals 39. And then we just have some basic practice here. This is 60, because this is 3 sets. See how it goes 3 sets of 20. Then 80 and 100. Now 100 is pretty significant, because this is one of the shortcuts that I found in Ancient Binary. So the significant thing about 100 is it's significant in the tens placeholder, but it's also a significant shortcut for counting and writing in Ancient Binary, because 100 equals 20 times 5. And so if we're counting by hundreds up to the 400s place, then 200 equals 10 sets of 100. And so basically, and then 300, this is another shortcut, 15 sets of 20. So basically this is, see we just put the placeholder here, this is 0, and then this is 20 times 5, because this is in the 5 place. Now we have 10. 10 times 20 is in the 200s place. And then we have 15. This would be 11, because 5 plus 6 equals 11. And then just move up, just add 4. 1, 2, 3, 4, yep. So then 15 equals the 300s place. So this is just a significant shortcut. And then of course, once we go to 400, 400 just equals the next placeholder. If we wanted 399, once again we cap out. Like 39, we cap out the basics here. So 399 basically be 19 sets, 19 times 20, then plus 19 ones. And then this equals 399 because this is 19 times 20 equals 280, and then plus 19 equals 399. Or kind of like 99 system in like those, but those are just a few basic shortcuts in this. And then just looking at this chart, and this chart only goes up to 8,000, but I do have other charts to go far, far higher. Some useless reason. I'm trying to think if there's a shortcut. So then you just count by 400s. Once you get to 3 digits, you just count by 400s. 400, 800, 1200. So then this is just one set of 400, 2 sets of 400, 3 sets of 400. And and then there is a significant shortcut with 5, because then you go to 1600. Yes. 4 sets of 400, and then you go to 2000. And right here, just like the 100s, is a significant placeholder, because for every 5 times 400 equals 2000. And so you can, if you're counting in the 2000, or if you're doing something with higher numbers, like in the 7000s or something, this is a massive shortcut to count by 2000s. Because basically, once again, this equals 2000. See, 4000. See, this is 5 times 400. Now, Now, basically, we then go to tens. 10 times 400 is 4000. And then see how helpful this is. If you're counting by 7,000, you can just cut to 6,000 directly. And then 6,000 once again equals 15. So this is 15 times 400. And so you can make a massive shortcut if you're adding and subtracting stuff by just saying 2,000, 2,000, 4,000, 6,000, and then you can just count by 5s and do this shortcut directly up here in the thirds place. And then of course 8,000 once again, and then I decided we put the dots here to represent that the number continues, just like commas in ancient binary. And as you can see, 8,000. So you can count by 2,000s to get to a 7,000 number or some of that sort a lot faster, and then it also helps with the 100s system every 5. So these are just 2 significant shortcuts that through studying ancient binary and everything, and studying the base 20 system, that I've just noticed, and I just thought they're just helpful shortcuts that you should know. On top of that, divisions takes a bit to get used to, but I think this will be in the next episode. But basically addition, so plus, minus, times, and division. So adding is up. See, because this represents, because addition goes up, right? So subtraction always goes down, so it's just a down arrow. Now basically, multiplication is addition on steroids. Multiply, basically on steroids. So basically it means, and it doubles all the time. So multiplication is just two arrows up, and then division with this number system is basically just basically 2 arrows down, because it's like twice as strong as subtraction. And so that's the basis behind these basic symbols of subtraction, addition. Anyways, so thank you for watching. This is episode of my Conlang and Ancient Binary, and tune in for the next lesson. Not sure when I'm going to put that out, probably next week. And this is Nature 1000 signing off. Bye one. Also, check out my VidMe account if you want to. It's also Nature 1000, and I will talk to you later. Bye.